Alright, so today we have to talk about how to find the components of initial velocity. So typically with a projectile motion problem, you're going to be given an initial velocity. And we have to take that velocity because it's going to be launched at an angle. So it's going to give us the velocity in terms of that angle. So we need to figure out how to split it up into its horizontal component, right? So that horizontal velocity, and then also that initial vertical velocity, so VI, Y. So if you notice from those vectors I just drew, we now have a right triangle. Right? We love right triangles because now we're going to work some trig magic into physics. Right? So you have this, you'll be given a vector, so like the white one I drew, and you'll know that initial velocity, it'll give you a number. So let's say it's 14.2 meters per second. And we need to split that up into its components. You're also going to be given a launch angle, and we'll say this one's being launched at 54 degrees. So, there's a really easy kind of like formula I'll give you to find each of these. So to find Vx, you will do VI times cosine theta. And then to find VIY, you will do VI times sine theta. So that's it. So for this one, you would do 14.2 times the cosine of 54. And then here you would do 14.2 times the sine of 54. And again, before you do this, make sure the calculator you're using is in degree mode. I know we had been using radians before in trig. So then the top one, that's going to give you 8.34 meters per second. And the bottom one, 14.2 times sine theta, gives you, and then sine theta gives you 11.49 meters per second. So that's all you need to be able to do to find those components. So that's really it for today. I've also attached some practice questions that deal with the notes from yesterday, and then it's also got several practice problems just with finding these velocity components.